Okay, here is our last learning video for OLI Mod 25. We're taking a look at a Did I Get This activity on page 168, which is actually a continuation of that drinking study and reaction times. This question is asking us to identify a type 1 error. So I have over here on the right a reminder of how we would commit a type 1 error. So a type 1 error happens when HO is true, but we rejected HO and instead accepted HA. So let me just remind us over here. So HO said that the drinking of the 2 beers has no effect on reaction time. And the alternate hypothesis was that the 2 beers increases reaction time. And in our hypothesis test, we rejected HO and we supported HA, which puts us in the category here of we could have created a type 1 error. The type 1 error specifically would be that HO really is true. For a type 1 error, whoops, the HO would in fact be true, and we should not have rejected it. So just thinking about in terms of that normal distribution, right? 0 was at the center, we were off to the left. We decided we were off too far to the left to believe that center could really be here. But remember, even when the center is here, things do exist out here. They are unlikely, they are rare events, but they still happen. Unlikely and rare events do happen. So this is when we make an error. We go back and say this is impossible because a rare thing happened, but in reality, a rare thing happened. So we need to look for a choice that says the 2 beers actually have no effect, but we rejected it. And let's see. So number 1, researchers conclude that drinking 2 beers slows reaction time, and this is true. Well, no, that's not an error at all. In reality, drinking 2 beers does not have much of an impact on reaction time. Oh, that seems like saying HO is true. But researchers concluded from this experiment that drinking 2 beers significantly slows reaction time. Yep, that is exactly the definition of this type of error. The HO was true, but we ended up supporting that alternate hypothesis instead. Okay, the last one here. The significance level is 0.05%, 0.05. So remember that we always compare our p-value to this significance level that we call alpha. And in OLI, we're generally using 0.05 or 5%, which is the probability of a type 1 error. And I just want to remind you that in reality, how you set this significance level is quite complicated. You have to assess what each of these errors will mean, assess which is worse, and then decide how to balance the probability of these 2 errors because they are at odds with each other. To make one smaller, the other one gets bigger. But how to find that balance is just beyond the scope of an intro to stat class. So we just say 0.05 and we leave it at that. But please understand that in reality, it's much more complicated. When the p-value comes in less than the significance level, then that is where we reject. And so then that's where we could have a type 1 error, because type 1 error is about rejecting HO. But as I've written here, the probability of a type 1 error is your significance level. So our answer here is 0.05. It has nothing to do with the p-value at all. We compare the p-value to alpha, but the probability of that type 1 error is exactly equal to whatever significance level you have chose to use.